Hi, my name is Dean, and this is my rendering project. What you see here is a simple scene with a capsule-shaped object that appears three-dimensional, but is in fact being rendered as a sprite. I can spawn thousands of these objects, rendering them all on screen while keeping a reasonable frame rate. To explain what's happening here, let me first show the scene created by Inigo Calez that demonstrates a technique of rendering 3D shapes by performing ray tracing against a scene for each pixel in the image. By rendering this way, shapes can be described mathematically in a shader. It's an interesting and powerful technique, but it would be very difficult to make a video game that renders like this. As an experiment, I wanted to explore a faster and simpler way of rendering these kinds of graphics in real time fast enough for games, by fixing the camera perspective and pre-baking 3D shape information onto 2D textures. For this to work, a shader is run to perform the ray tracing against a 3D shape and output the result into a texture array like this. On the left-hand side is a color map. On the right-hand side is the normal map. This tells us the facing direction at each point along the object's surface. When it comes time to render, I simply draw the sprite and use the normal map to perform very standard lighting calculations used by most games. Here I've commented out an important line of code. Can you see anything wrong with our asteroid? The lighting appears to be rotating with the object, as if the light is orbiting it. This is because as the shape rotates, so do its textures, and so does the normal map used to calculate the lighting. To fix this, the rotation of the shape is encoded into the vertices, and I apply that rotation to the normals inside the shader. This project is using my custom game engine, which is written in C++ and using OpenGL to render. The engine allows for hot reloading of game assets. This means that images, fonts, audio files, and so on are reloaded automatically when they are saved to the hard drive. This means I can have the game open and make modifications to my shader that generates the shape textures, and see those changes occur in real time. As well as supporting hot reloading of game assets, I can also compile the C++ code of the game layer and reload it as a DLL at runtime. This way I can make changes to my C++ code and see those changes take place without having to close and reload the game. Here is an asteroid I created by sampling noise textures and applying them to a sphere. I can change the radius of the object, making it smaller or larger. You can see though that if I make the object too big, it clips outside the boundary of its sprite. I can change the strength of the noise effect applied to the object's radius, making it appear rounder or more warped. I can change the UV coordinates, making the texture on the object appear larger or smaller. I can cycle between a collection of hand-picked noise textures, changing the surface texture of the object. I can change the strength of the normals, making the surface texture appear more deep or more shallow. Finally, I can change the color of the object. Here, we can see a large number of the sprites being rendered. As we can see, the performance characteristics of this more complex object are similar to that of the simple capsule we were rendering earlier. Thanks for watching. This is an ongoing project, and I hope to have more to show in the future.